how are you? Good afternoon, can you hear me?
Yeah.
Hi, you can unmute. So I'm requesting that you check for me so that just one of you go if the board is visible. If not, you tell me so that I can rectify. It's being written on the board is visible. Confirm if you can hear me very well from the side of YouTube and from the side of Google Meet so that we can proceed. If you can hear me, just indicate a comment so that you can hear me. If you can see what I've written on the board, still write so that I can actually confirm on the same. Otherwise, how is your afternoon? How are you doing? Okay, so we can proceed. And today we are discussing simple classification of substances. Just like I had said in our WhatsApp group, those we share the same WhatsApp group, I do make communication there. At the same time, I will be sending past papers there. I will be giving exams there, which you will do, then we mark it from my channel. So today I just delayed kidogo because kuna tu mahali nilishikana kidogo. Otherwise, every day from 2 up to 4, we shall be having chemistry and physics lesson. Now, today I will be sending an exam on physics, which you will do it, then we will mark tomorrow in the afternoon. Somebody saying that I only can. You cannot see the board. Timothy, you cannot see what is written on the board?
Yes.
Okay. So I will rectify that. So allow me to share the screen on a simple classification of substances. Then I will rectify the screen for the sake of those who are watching me. Kwa nyinyi wengine wenye tuko, allow me to share that particular simple classification of substances. And those who are watching me, if you can comment where you are watching me from. Then last time we finished on chromatography, and today I will start by asking a question on the applications of chromatography. Yeah, if those who will be in a position to answer me. So we have actually 4 applications of paper chromatography, which I will start by asking that particular question. Then we'll proceed. I had actually discussed the application last time, but just to see whether you guys still remember, I want to start by one of you giving me applications of paper chromatography. I've shared those in Google Meet. Those who are watching me, you can write your application. What do you think is the applications of paper chromatography? Yes, so it has 4 applications. So you are free to, yes, tell me the application. Yes, so DJ Shuan is following us from, I don't know, somewhere in Makwe. Yes. So we have 4 applications which I can read it for you for today. The first application is it is applied in sports to be used to identify the banned substances. For example, if there is a drug that athletes use so that they can run very fast, what is there is before you participate in a race, you do what you call anti-doping. So that is what we apply. We apply paper chromatography. It will point out steroids in your urine. So now that's one of the applications. Another application is in the pharmaceutical industry. To test for purity of drugs. After drugs have been manufactured, it has to be confirmed that these particular drugs are pure. It doesn't contain substances which is not supposed to be part of the medicine. Number 3, we have what we call in cosmetics industry to identify harmful substances. And lastly, in food industry to identify contaminants in drinks and in food. So those are the 4 applications. Unless you have a question, we will look at something else, effects of heat on substances. We shall be checking on that in our next discussion, which is starting in the next 1 minute. Okay, those who are following me live, you can tell me where you're watching me from as we are getting ready to start our lesson on effects of heat on matter. We are going to see very many things. We're also going to discuss on elements and their symbols. It's a Form 1 work, but I encourage Form 2, 3 to be attending it. By next week, by the way, I will be done with Form 1 work. I will be starting Form 2 work, but for this week, allow me to continue dealing with Form 1 work. Like on Monday, we will be discussing on acids, bases, and indicators. So keep on every day, be here, be following me from 2 up to 4 p.m. Yes, and if you have any question, you can easily ask. Like, there's someone who had texted me kwa WhatsApp, akaniambia kona swali. Kamwambia swali gani? Wacha niangalie. So the question was let me see the question. Okay. The question is, why is filtration preferred to decantation in separation of substances? Why is filtration preferred to decantation in separation of substances? Who can try that one? Why do we prefer filtration than decantation? What can you say? I mean, during separation of substances, filtration is a method and decantation is still a method. For example, if we have sand and water, we can separate via filtration or decantation. But why do we prefer filtration over decantation? Yes. Beverly, what can you say? Beverly, will you come answer the question? What can you say, Eunice Gina? Just a minute. So let's look at our today's topic. We prefer filtration over decantation because in decantation it can still allow small particles to pass through. So we prefer decantation because of filtration because of one reason. It does not allow small particles to pass through. Now, Munga, you can check for me if now the board is visible. If you can see what is written on the board, Munga. Check from your site on YouTube. Then Niambie, I want to look at the states of matter, effects of heat. So, our topic is effects of heat on substances. When we talk about effects of heat on substances, do not be biased. Ensure you talk of both cases, whereby when we add heat, what will happen to a substance, or what will happen to a matter? When we remove heat, what will still happen to that particular matter? So now, you can see that. Munga confirmed that now we can see what I'm writing on the board, which is okay. So when we add heat to a substance, of course, it has its own effect. When we remove heat from a substance, it has its own effect. I remember some students who were given a question on Kadua, state the factor which changes the state of a matter. And they were not able to answer it. Yet it's something very simple. The factor which, when it is varied, it changes the state of a matter is heat. When you apply heat, the state will change. When you remove heat or you cool, the state of the matter will still change. So what am I saying here? We have three states of matter. We have solid, liquid, and gases. Now, if we have three states of matter, then if you apply heat to a solid, it will change to a liquid. Regardless of what kind are you talking about, it has to melt. The same happens to liquid. They have to change state to gas. It will not change state. It will just increase in temperature, but the state. So what am I saying here? When you cool a solid, it will not change state. So as long as I'm saying that I change in or a variable temperature changes the state of a matter, not all of them. Because if you heat a gas, there is no any other state above the gas. So what is there is this. Let's see how the effects of variable of heat affects the state of matter. In most cases, we use naphthalene or we use ice. When we use any of the two, we'll be able to get the concept I'm talking about here. Now, if you heat naphthalene or you heat ice, after some time, they will change to liquid water and liquid naphthalene. Yes. Number two, the temperature at which the ice changes to water is different. The naphthalene changes to liquid. We call it the melting Now, this melting point is the temperature at which a substance changes from solid to liquid. When defining it, the examiner will always be looking for a word like the fixed temperature at which a solid changes to liquid. It varies depending on the substance. In Form 2, when you learn about the bonding and structure, that is one of the factors that affects the melting point and boiling point. Why water will boil at 100 while ethanol will boil at 78. That's the point. Now, when in most cases we always use a graph or a curve to show the effects of heat on a matter or a substance. We will call it a heating curve. And when we use a graph to show the effects of heat on when we cool a substance, we call it a cooling curve. We are going to see together one by one, especially if we have those who are following. Look at the naphthalene. When naphthalene is heated, it will melt to liquid. If you continue heating, it will change state to a vapor. Now, let me draw it on the board so that you can see it, those who are following me. Now, look at what I got. A graph, you always have an arrow to show that a process is continuous. Now, ikiwa hivyo, what can happen here is I can show you how the heat affects. I'll use naphthalene as an example, but you can choose to use something that you want to use on your own, right? So, if you heat naphthalene, maybe, of course, at room temperature, ukiachanga heat side like in this room, like in this water now. This water is, I'm sure it's at room temperature, around 25 degrees Celsius. But if the room is cold, it may be at 15. So if I apply some heat to naphthalene at 15 degrees Celsius, it will rise this way. Ikifika hapo, it will flatten. Ikisha flatten hivyo, then kumaanisha, this side is temperature in degrees Celsius. Now it could be heat ama time in minutes. You can talk about time on site, time in minutes. So after some time, the temperature remains constant. But when we are starting the process, at a given time, it is rising. Ikifika mahali fulani, it flattens, meaning there is no recorded rise in temperature. Why? I will explain. Then from there, it will start to rise again. Ikifika mahali fulani, it flattens, then it rises again. This is called a heating curve. I will name here A, I call here B, I call here C, I call here D, E, then F, A, B, C, D. We are going to explain what happens in each step. We're going to explain what happened in each step. Good. So we have this step A, B. I'm a stage A, B, whatever you call it. Can you see what I'm writing on the board, girls and boys? Someone to confirm that you can see what I'm writing on the board?
Yes.
Okay, sawa. Now, ukiangalia nimeandika we have A, B, C, D, E, F. Mostly unaambiwa explain what happens in stage. Ama step A, B, 2 marks. B, C, 2 marks. C, D, another 2 marks. D, E, 2 marks. E, F, 2 marks. Examiner can try to give out 10 marks, 1, 2, 3, 4, 5. And you're supposed to explain what happens in each step. So that tuanza na AB. there are things that you are supposed to write at stage A, B. One, you are supposed to say the temperature of the naphthalene rises. So the temperature of the naphthalene rises. That is true. That's why you can get 1 mark or half a mark, depending on the first marking. And also depending on the question, how many marks you can go awarded. The temperature of the naphthalene increases. APA rises, and all of us we can see. Then, the other thing that happens at AB is the kinetic energy of the particles, molecules of naphthalene increases. So, tunakumbuka venye solids, the particles imekaa hivi. This is that's what increases. And the vibration of the particles, niliwaambianga the other day, when discussing this topic, the word particle is interchangeably. Now what I'm saying is, so apart from the temperature rising, apart from the kinetic energy increasing, vibration of the particles increases. So remember AB, 3 things take place at AB. Who can repeat what I've just said at AB? Okay? Remember anything that take place at AB? Yes, Reagan?
As the temperature increases, the force between the particles is weakened.
And therefore, when the force is weakened,
and the particles move further, turning into a liquid.
Before they turn into a liquid, what happens? They vibrate. The rate of vibration in an increase of these particles, they vibrate within a fixed position. Good. Now, BC. At BC, the temperature remains constant. Why does the temperature remain constant? Michelle, you can do it. Kama uko na swali, unaweza uliza. Michelle, naona wewe uko na swali lakini nataka tuone swali gani. Now, to go point BC. The temperature remains constant. The temperature remains constant at point BC because of this reason. The heat supplied is being used to change the state. So there is no available heat to make the temperature rise. Are you together? The heat supplied is being used to do what? To raise the temperature. The heat being supplied is used to change the state. So there is no heat available to change or to raise the temperature. So it will remain constant until all the naphthalene melt. You can write that one. You can write it somewhere. We can proceed, right? Someone wants to join class, let me admit. At CD, first of all, let me write something here. Let me just say this, that hapa ni solid, hapa ni mixture of solid and liquid. because we have the melted naphthalene, which has already to melt. So upper, this part is liquid, upper is liquid. What takes place between C and D is the rise in temperature. The temperature rises simply because the heat is being supplied and it's not changing state. And at point C, the kinetic energy of the particles of the liquid naphthalene also increases. Number three, the vibration of the particles increases. And remember, the particles, the force holding the particles together have been weakened. Yes, so that is between C and D. Let me give 1 minute, let me just do some settings. Don't go through the last one. We proceed as one of you will come and tell me what happens at between state D and E. Umeelewa ile swali kulikuwa umeniuliza?
Teacher, I had asked the one for to name another method that could be used to obtain common salt without watering.
This 5 Roman to name another method that could have been used to obtain common salt. Water not required.
Okay.
So we are at this point. What happens between point DE? Why is the temperature remaining constant? Because the heat supplied is being used to do what? To change state from a liquid to a gas. So at point DE is a mixture of the gas and the liquid, naphthalene. Then EF is a fed bar. We call it, okay, let's for now. EF. When you heat EF, at the which temperatures it will remain gaseous state. That is an example of so upper the gas, upper the mixture of a gas and a liquid. So those are the steps that you're supposed to know as far as explanation of a heating curve is concerned. Yes. Someone is watching it from YouTube. You can confirm if you can see something on the board. Yes. Allow me to sketch a cooling curve. This is called a heating curve. This one. It's called a heating curve. It's called a heating curve. A heating curve. So, can I get to the cooling curve now? Nani wana swali ya heating curve? So can we get to the cooling curve? Janice Mumbi.
Yeah.
Umeelewa hiyo? Kuna maswali zitakuja after this right now, so make sure umeelewa. Let me clear the board now. Cooling curve. Degrees Celsius and this is time in minutes. Yes. So this it is the opposite of what I was just explaining in the last few minutes about between AV, this one is a gas. Hapa ni mixture, na nikisema mixture ushike ni mixture ya nini? Ni mixture ya gas which has already changed to liquid and some gas which has not changed. Hapa is another mixture of liquid and solid. So when you are cooling a substance, you are simply removing heat from it. And therefore, when you are removing heat from a substance, you are lowering the kinetic energy and you are increasing the forces of attraction between the particles or simply between the molecules. Yes, that's what you need to know. Number 3 also, when you are removing heat, you are increasing the force of attraction, and therefore you are reducing what we call intermolecular forces of attraction. So the distance will reduce. Kumbuka, if these are the distance between the particles of a gas, the molecules of a gas, for a liquid they are close to each other, but for solid they are in contact. By the way, the distance between the molecules is measured in what we call nanometers, nm, nanometers, which you use nanometers in the file way. How do you convert from? It's called nano. More length. When you go to campus, you will be doing these things. Very short length. In fact, you cannot measure it with any measuring. You can simply convert. The kama jana nikifunza about microseconds. Some of you say 1 second is 1 million microseconds. You want to say but that's how it is. So these results are very small. We measure them in terms of nanometers. We measure a distance. We measure distance in very high, meters, centimeters. Somebody has raised a hand. Juliet, you have a question?
Sir, can you raise it because I can't see well?
Madam, you can't see?
I can't see the board well. Let's slightly big.
Oh, you go kubwa kidogo? Yeah, I will. In fact, I will try it very big now. Are you seeing a curve, a cooling curve?
Pardon?
Are you seeing what I've just drawn on the board? Can you see something?
Yeah, only the curve then. Yeah.
I and C here. And E at
Yeah.
Okay, then we have E, then we have F. Sawa? Now,
Yes.
between A and B, the state of that particular matter is a gas. What happens at AB is the temperature lowers because cooling is taking place. And therefore, the kinetic energy between the particles of the gas at AB decreases. And the distance of the particles in the molecular distance, as we can call it, decreases. Between B and C, there's a change of state, whereby between B and C is a mixture of a gas and a liquid. The temperature remains constant there because even if you are cooling, it is now changing state, so it has to remain constant. Between C and D, it's a liquid. There are two things that take place at C and D. the kinetic energy decreases, then the intermolecular distance also decreases between the particles of the liquid. Why? Because it's equal. And also remember the temperature is getting lower. The DE is another change of state from liquid to a solid. Here, at this point, when you ask what is the state of naphthalene between D and E, or of ice, depending on the material you use, is getting lowered. Kama kuna swali, you can ask me as we are moving on. Okay, so Mr. on time, it will be okay. Sawa Julie. Yes. We can proceed. But focus on what I'm writing. So, nataka tuendelee kidogo. I want us to look at what we call, okay, I will not talk about the heating of water because I've seen, but kuna kitu fulani nataka niongelee. How can you use a heating curve to distinguish a pure substance from impure substance? How can you use a heating curve or a cooling curve to distinguish between a pure substance and that of impure substance? Let me hear from you, one of you.
If you heat the substance and it has a sharp corners on the boiling point, the substance is pure.
Malaysia?
But if the corners are not sharp on the boiling point, the substance is impure.
Now, look here. We have A there. Then we have B. Between A and B, which one shows a heating curve of a pure substance? For those who can see it. Are you seeing what I've done on the board? Now, A, big that one of you can see it's very sharp. It's very sharp. But for B, it's not sharp. It's colorized. So A is for pure. B is for impure. Tuko pamoja. Sawa. Let's proceed now. A pure substance like water melts at a constant. By the time it is shifting from 0 to 1 degrees Celsius, all the ice has melted. But if it is not pure, itaanza kumelt na -1. Ifike 0, iendelee kumelt even up to 1 or 2 degrees. Will melt at a range of temperature, range from this to this. Lakini kama I'm telling you, I don't want to talk about the name of the change of state from solid to liquid is called melting. Hiyo nakuwa nimewadharau sana. Kisikia mtu anakufunza nakwambia the name of the process is melting and from liquid to solid is freezing. And from liquid to gas is evaporation. And from gas to liquid is condensation. We don't know what the house is that the one that can change directly from solid to gas, the process is sublimation, and the opposite of sublimation is deposition. Now let's look at what we call kinetic theory of matter. Kinetic theory of matter. In this theory, we always say that matter is made up of particles which are in continuous state of motion, and the particles are represented differently because of the difference in the forces of attraction. What then what we talk about so that you can see the difference actually? Yes. Those are the particles of a solid. I don't know whether it is clear. Sitaki watu wangu wakose kuona. Mtakumbuka tu mstari. As things goes by, things will be okay. Yeah, liquid iko hivi. This is for solid, this is for liquid, and this is for gases. Okay, what am I getting again? For gases. I think you can see it right now. So we can discuss from that particular point. For the solid, they are closely packed in a definite pattern. Why? There is a high forces of attraction. We call it the intermolecular force is very high in solids. In liquids, the intermolecular force of attraction is less compared to that of solids, but greater compared to those of gases. Now, the intermolecular distance of liquids somehow go more compared to those of the solids, but less compared to the ones for the gases. Are you together? Julia, can you see my board very well? So that's how it is. That's the intermolecular force of attraction that is responsible for the position of the particles. Yes. These ones, the particles are widely separated, and the particles are independent of each other. The particles are close, but not like those ones over there, solids. And they move within the container. This one, the particles are in a fixed position. And I think I've explained that. So let's not get there so much. Now, I want us to let me say this. Now that we have said that impurities affects the melting point and boiling point. To be very specific, impurities lowers the melting point and raises the boiling point. What is the application? It has two applications. One, clearing of ice from roads in winter or the temperate countries by spreading common salt on the ice. Then we have extraction of metals from their ores. If you from 4 atomic called metals in chemistry, you will be able to learn from it very well. So that's the point. If you have any question, you can put it somewhere there. Criteria of purity. Pure substance melt and boil at a constant temperature, which are very specific to a given substance, like water, it is 0 degrees Celsius. But if it is not pure, it will remain at a range of temperature. Good. So, I want us to go back to some questions kidogo. I want us to go to the questions kidogo. But before we look at the questions, there's what you call constituents of matter. In our lesson on Monday, before we start what we call acid-base indicators, in our lesson on Monday, I would discuss what we call permanent and temporary changes. But for today, I will look at the constituents of matter. After looking at the constituents of matter, we look at some few questions here and there. So there are some terms. There are some terms that you have to master them. If you cannot master them, then you go ahead and you cram them, because you have to have them in your brain. Upper and lower option. Now, we have the following terms. One, element. I will clean the words so that we can define them. Okay, towards an element. To number 2, atom. To number 3, molecule. We have compound. Then we have mixture. We have mixture. Haya, nataka tuanze kudefine those terms. Element, atom, molecule, compound, and mixture. Iko poa? In fact, nikueleza tunakuja tukimaliza. So, what is element? What is atom? What is molecule? What is compound? And what is a mixture? I just picked the first 5 people to answer me that question. You just pick yours, unajibu tukisonga mbele. Tuanze na nani? Hello. Popo. In fact, wewe tembea kwenda mimi nilitoka kwa nyumba asubuhi mapema. Nilitoka hata niliamka tu kama haiko nikaja kumtalipa na mimi nikatoka sasa sasa. So mshamaliza hiyo shift yenu. Uko ni mkazi. Itu kena laboratorium kita. Situ betul. Ini tu si buku ni tu. Si militer kwa shule nikaenda matembezi katika tunaanza ini. Hapo tunaanza tulienda tu prepare mimi nikatoka. Mimi sisi nenda. Sawa, wawaja nakukole. In fact, sawa. So which one will you define? Element, atom, molecule, compound, and mixture. Beverly anatuambia atadefine gani? Reagan utatubia gani? Even those who are watching me live, you can type your definition. We are defining the terms you are seeing on the board. We are defining element, atom, molecule, compound, and a mixture. Hata nianze na Wahome, pick one term and then define. Of those terms are given. Then Michelle Mungai, get ready. Followed by Mercy, Janice, and Britannia. And we try to save time, Giro.
Number 2.
Okay.
An atom is the smallest particle of an element which can take place in a chemical change.
Yes, which can take part in a chemical change. The smallest particle of an element which can take part in a chemical change. Aya, Michelle amesema hana network lakini anataka. Juliet Mas. Okay, wacha niende kwa Janice.
A compound.
Yes.
A compound is a substance formed when two different elements are chemically bonded together in a fixed ratio.
Kabisa. So, we will, after this, we are going to see examples of compounds and the elements making up the compound. And if you have to separate them, you have to use chemical means. Back to, let me, Alana, can you answer one? So, E imesema compound has gold, atom has gold. Alana? Okay, tuachana Alana. Back to home. Wahome, can you? Hiyo ni kama huwa kumajui. Janice, nikalo utadivide. That one is very dangerous. Aya, sawa. Let me see kama watu wa YouTube wamejibu. Wao pia wajui. Aya. Twende basi. Can you take your pen write this then? Now that naonyesha ya kwamba so those are the element. Pure substance which cannot be split into simpler substance by chemical means. A pure substance that cannot be split into a simpler substance by chemical means. That is called element. Molecule is defined as the smallest particle of an element or a compound which exists separately. The smallest particle of an element or a compound which can exist separately. Like this is a compound, ammonia, inaandikwa NH3. This is called ammonia. It's a molecule. Hydrogen inaandikwa H2. It is a molecule. Lakini nikiandika H alone, this is atom and this is a molecule. That is the difference between the two. So that is a molecule. That is the element. Now we are dealing with a mixture. Who can wait for us to the term mixture then? Two and can be separated by physical means is a mixture. By the way, I want to demonstrate. Look here, everyone. Look here very fast, everyone. Angalia hapa kila mtu. We have if you have ion filings with sulfur, just mixing. Yani umechukua spoons mbili, this is a mixture. In this mixture, you can still be able to see with your eyes the gray particles, of ion filings and the yellow particles of sulfur. Why? Because it's a mixture. But if we have ion filings with sulfur, then you heat. Heating means, for iron and sulfur to react, it needs heat. Then you heat. It will change color. It will give you a substance which is black. We call it iron 3 sulfide. Sometimes it can form iron 2 sulfide. It is black. It is something different from hata ukijaribu kuangalia hivi, you cannot see any gray particles of iron filings or yellow particles of sulfur. No, you will see a black substance. It's a compound. If you have to separate these two, unless by chemical means, like ukitaka to separate iron filings from sulfur, you pass a magnet and you'll be able to separate them. Yes? Yeah. So that's the difference between a mixture. So in compound, it's a compound now. But clearly, mixture. To go pamoja. Can you proceed? Say yes or no. Can you proceed? Okay. Juliet amesema you can proceed. Now, we can proceed. Let me clear the board. For those who are following me from YouTube, nimeambia mnisalimia, andika tu hi, at least nijue wanafunzi wangu wanasalimia. Now, let me explain this. Somebody who was defining compound alisema hivi, 2 or more elements chemically combined, it forms a compound. Look here. Somebody who is watching from YouTube, can you see what I'm writing on the board? Just 5 years or no, kama unaangalia. Look at this. Sodium chloride. Can you see it? Then we have sodium sulfate. Sodium sulfate. Then we have sodium sulfide. Then we have sodium. Sodium sulfide. Sodium sulfide. Now, I want These are compounds. The first compound I've said sodium chloride, sodium sulfate, sodium sulfide, sodium sulfide. Mkande always can differentiate easily sulfite and sulfide. Anyway, it is out. So I want us to name the elements present in these particular compounds. Thank you, Amy, for confirming that you can see what I'm writing on the board. Nataka tuanze at the first compound, sodium chloride. It is made up of sodium and chlorine. It is made up of sodium and chlorine. Ya pili, sodium sulfate. Angalia, ukiona compound inaishia na ATE. ATE. You the oxygen. So sodium sulfate is made up of sodium, sulfur, and oxygen. Sodium sulfite, pia ITE. Ukiona ITE, it's made up of oxygen. Sodium sulfite, sodium, sulfur, and oxygen. What is the difference? Okay, kuna mtu ndamwongelea sasa hivi. Now, the difference between sulfate and sulfite is sulfate has more oxygen, sulfite has less oxygen. Wacha niandike the formula of sodium sulfate so that whatever inaandikwa. Sodium sulfate. Umeona nimeandika how many oxygen atoms? 4. Lakini sodium sulfite naandika hivi. I think now you can see what that is. Simply sodium sulfate, sodium sulfite. Sodium sulfate is made up of Na2SO4. Sodium sulfide, Na2SO, or in SO4 in SO3. I think what I'm talking about. Somebody is saying receive love from India. India. I will come to India one day. Emmy is watching from India. Emmy, but thank you for watching me. Please, you can share my channel. I always teach from 2 to 4 p.m. And thank you for that. Now, today, sodium sulfide is IDE. Now, this one, it is made up of sodium and sulfur only. Sodium and sulfur. He given the sodium and chlorine. So, formula is sodium chloride. Formula is sodium sulfide. Sulfur got a valence and sulfur 2, going to valence 2. So it's going to be Na2S. It is also F valence sulfide, India sulfate, sulfite, India sulfate, India chloride, sodium chloride. Mpaka hapo umeelewa kenye nimesema? Someone to confirm from YouTube that you can understand me. Kama tu umeelewa kenye nimeeleza hivi, you say yes. As I also try to hear from those who are who say that. Thank you.
Yes.
Yeah, thank you, Wahome. So I want us to get some questions here and there. I want us to get to these particular questions like name the elements present in sodium hydroxide. Sodium hydroxide. Those who are informed kidogo wanaweza kosa kuelewa hiyo, lakini forgive me. Next week I will teach you about chemical elements and compounds. Sodium hydroxide. Elements present in sodium hydroxide. Write for me on the comment section and on the chat section. on the comment section and on the chat section. Those who are on YouTube, just on the comment section, what are the elements present in sodium hydroxide? Na nyinyi wenye mko side nyingine mniandike kwa chat section, what are the elements present or making up sodium hydroxide? Yes. What are the elements making up sodium hydroxide? What are the elements making? Yeah, I can see someone has raised the hand. Okay, so no. Text Michelle Mungai, a good friend of mine, and said sodium, hydrogen, and oxygen. Yes. Let me hear from sodium, water, and oxygen. Let me. Somebody else says sodium, hydrogen, and oxygen. Good. So allow me to explain this. Angalia hapa everybody. Mwaso Emi, look here. Sodium hydroxide is written this way. Check on my board. Sodium hydroxide. Nimeandika kubwa because kuna mtu anasema aone vizuri. Yes. Kiangalia pale sodium hydroxide. What can this be? First of all, we have sodium here. Can you see that? Number 2, we have oxygen. Then number 3, we have hydrogen. Those are the 3 elements making up sodium hydroxide. Nataka nipeane ya mwisho. Write for me the elements making up aluminium carbonate. Just those who are following on the YouTube will what chat comment section. Watu wangu wa Google Meet mniwekee kwa chat. Aluminium carbonate. And I would like us to go and answer some few questions. But first of all, for you to understand this, Wahome Mungai, you will forgive me kidogo because I know I'm the cafe. But aluminium carbonate, first of all, write its formula. Then give me the elements making up aluminium carbonate. What 1 minute? Tuanze kidogo. Binti anasema Ami amesema aluminium carbonate oxygen. Thank you. Ami, you are very correct. Binti amesema aluminium, oxygen and CO2. It's okay, but hiyo CO2 nataka usplit. Nataka useme kama vile Ami amesema. Aya. Michelle, I'm waiting for your text.
Yeah.
Look here, everyone. Dindi, check here. Aluminium carbonate inaandikwa hivi. This aluminium carbonate. 2 aluminium, then carbonate in bracket. So in simple terms, it is made up of aluminium, carbon, and oxygen. Aluminium, carbon, and oxygen. I hope we are together there. I would like to stop there for today. We shall meet. Kuna paper Juliet Mason nimereceive text yako aluminium carbon and oxygen well. Kuna paper ya physics ya pressure ndatuma kwa group leo. Make sure you revise. We shall be discussing it tomorrow from 2 mpaka 4 tomorrow afternoon. Yes. So somebody is raising hand for comment.
What about the question?
Oh, sorry. Let me check that question. Where is the common salt? Mixture C is made up of copper 2 oxide and common salt. It was evaporated to dryness using a sand. While it was water by the head sour, name another method that could have been used to obtain. Hii method nyingine iko sawa, lakini iko mbele yako, inaitwa fractional crystallization. Wahome andika hiyo fractional crystallization. Sawa.
Yes.
Yeah, you can write it fractional crystallization. Dindi, welcome so much. See you tomorrow from 2. Are you doing physics, Dindi? Kama unafanya physics, sema yes. Lesson on moles I was supposed to do it tomorrow. Let's do it on a Sunday. Moles. No, but kesho wawacha nifanye pressure. Can you agree? I read my WhatsApp group, Nani. I read the WhatsApp group. Beverly, tufanye nini hiyo lesson ya moles? I need a big time. Tunafanya next Saturday asubuhi. Why don't we do moles next this Saturday from 8 a.m. mpaka mahali itafika. Let's market that. It's going to be a very good one, and I will do it on the site of the YouTuber because the weekend. So you sitafanya na Google na because nataka ndio naandika fast kidogo nafanya kwa upande ya YouTube. So definitely nimekuachia, can you market that one? Tukutane saa 2 from 8 to whatever time tutamalizia ku discuss moles. Dindi amesema anafanya physics. So are you in any of my WhatsApp group, Dindi? I send you maswali ya kesho yenye tutadvise kesho. Ami, no problem. Ami is from Kibiringi. Thank you girls and boys. Receive a lot of love from Ambassador Foundation. Emi, sawa. Emi, wewe kesho my channel will miss you. You will not be. But tomorrow join for physics. Now we want it for like 2 minutes. Nani? Dindi can you WhatsApp this number? You will be added to our WhatsApp group 0740619025. Nimeandika hapo kwa chat. So that number, copy that number. Just say add me to the WhatsApp group. We will add you to our WhatsApp group where we share resources. Right together, Lily. Sawa sawa. Have a nice day.